Assalamu alaikum students. Hope you all are fine and enjoying your studies at home. You are listening to your chemistry teacher, Miss Hana Islam. Today we are going to study about chapter number 5, Physical States of Matter. Topic 5.6, Allotropes of your book. Page number is 98. The question arises, what are allotropes? Which type of categories of the elements fall in this type of elements? So, in nature, we easily found some elements which exist in more than one or two arrangement of atoms. Such elements, or we can say that different form of the same element which are found in nature in different arrangement of atoms are called allotropes. In simple word, we can say that if an element found in nature in more than two or more different arrangement of its atoms, these different forms of the same element are called allotropes. For example, you can see in this picture, one is the carbon, which is your graphite, black, first from your left side, and second is the diamond. It is also a form of carbon. And in the third and fourth picture, from left side, you can see the arrangement of atoms. There is a different arrangement of atom. In diamond, each carbon atom is bonded to 4 other atoms, creating a rigid compact array. This makes the diamond hardest known substance. Whereas in graphite, carbon atoms are arranged in layers of hexagonal arrays. You can see in the last picture from the left side, weak bonds exist between the layers that allows there to slide over one another. This makes graphite soft and buckyballs. In graphite, 60 carbon atoms are bonded with the other carbon atoms to give you a hollow sphere shape. Carbon atoms arranged in diamond, graphite, and buckyballs are called allotropes of carbon, pentagons, and hexagon, just like a saucer ball, because all are made up of carbon atoms and are solid. So, the standard definition of the allotropes is the different forms of an element in the same physical state and phase are called allotropic form or allotropes. Again, I am repeating, the different forms of an element in the same physical state and phase are called allotropic form or allotropes. So, here in another picture, you can see the structure of diamond and the structure of graphite. There is distance in pm. You can see in diamond it is 154 and in graphite it is structure of the atom is 142. Diamond, students must note it, Diamond is the hardest known substance in the universe, and graphite is the soft one, but not the softest in the universe. Now, allotropes of phosphorus. We have seen that carbon exists in two important forms in nature. One is a diamond, another is a graphite. Just like another common non-metal, phosphorus is found in two common allotropic forms known as white phosphorus and red phosphorus, and black is the common one. The white phosphorus consists of tetraatomic molecule or normally P4 that are not bonded to each other, whereas in red phosphorus P4 molecules are bonded to one another in long chain. You can see from the left side, first one white, it exists in non-bonded form where the four phosphorus atoms are connected with each other. Whereas in the red one, you can see there are two atoms, two molecules you can see, and it contain one shape, four atoms. This is your long chain of red phosphorus. And sulfur consists of molecules that contain 8 atoms. S8. Sulfur also exists in several crystalline and amorphous forms. Kindly note it, students, that sulfur also exists in several crystalline and amorphous forms. Rhombic sulfur and monoclinic forms are its important crystalline forms. Kindly again note it, rhombic sulfur and monoclinic sulfur. These are the forms of the sulfur are important crystalline allotropes of sulfur, whereas plastic sulfur is the amorphous form of the sulfur. Again I am repeating, plastic sulfur is the amorphous form of the sulfur. Now our another topic is 5.7, comparison of physical states of matter. Here we are going to differentiate between the three states of matter with regards to their intermolecular forces present between them. You know very well there is no attractive force between the molecules of gas, so they can move freely in all directions. A gas has no definite shape and definite volume. I am again repeating, a gas has no definite shape and volume, but molecules, there is a significant forces exist between the molecules. These forces keep molecules together. However, these forces can't hold molecules in fixed position. So, after that, we have a liquid. Liquid have a definite volume but no definite shape. Whereas in solid there is strong forces between the particles. These forces are strong enough to hold particles in fixed position. As a result, solids has a definite shape as well as definite volume. In this picture, you can further see that in the diagram, solid has definite shape, definite volume, liquid have definite volume but no definite shape, and gases have no definite shape and no definite volume. Common example is a rock, solid, water, liquid, and water vapors, gas. After that, in this picture you can see we have studied melting point, freezing point. Solid is converted into the liquid, it is your melting. Liquid is converted into the solid, it's your freezing. Liquid is converted into the gas, it is your vaporizing or evaporating. And gas is converted into the liquid, this is your condensing. After that, you can see in the picture, there is a comparison of the solid, liquid and gas. Thank you so much. Stay blessed. Keep studying.